episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor. Welcome everybody again to another episode of our show with another really fascinating guest for you today, involved in creating a better tomorrow on many different fronts, some very exciting areas we're going to be touching on today. And we have the opportunity of being joined by Dr. Missy Cummings, professor in the Department of Electrical and Computer Engineering, Pratt School of Engineering at Duke University. She's also a professor in the Duke Institute of Brain Sciences and the director of the Humans and Autonomy Laboratory in Duke Robotics. Dr. Cummings received her bachelor's degree in mathematics from the United States Naval Academy, her master's in space systems engineering from the Naval Postgraduate School, and her Ph.D. in systems engineering from University of Virginia. Dr. Cummings was also one of the Navy's first female fighter pilots, earning the rank of lieutenant, serving as a naval officer and military pilot 1988 to 1999. Her research interests are quite broad, including human-unmanned vehicle interaction, human autonomous system collaboration, human systems engineering, public policy applications of unmanned vehicles, and the ethical and social impacts of technologies. Dr. Cummings is an American Institute of Aeronautics and Astronautics Fellow and a member of the Board of Trustees. She's on the Defense Innovation Advisory Board, and she's on the Board of Directors of the Veneer Company, which is an auto tech company that produces sensors and control units for automated driving systems and so forth. Dr. Cummings previously served as an instructor for the United States Navy at Penn State University. She was an assistant professor at Virginia Tech in their Engineering Fundamentals Division and associate professor of aeronautics and astronautics at MIT. In addition to all that stuff, she is also an accomplished author. You can pick up her book, Hornet's Nest, the experience of one of the Navy's first female fighter pilots, on Amazon. And a couple of fun facts here. Her call signs when she was a fighter pilot included both Medusa and Shrew. Pretty cool names, a Shakespeare reference. Dr. Missy Cummings, thanks so much for taking the time to come on the show today.
Thanks for having me.
It's really great. I'd love to start things off like we typically do, just by handing you the floor for a couple of minutes to talk about your background, how you got interested in sort of joining the Naval Academy and becoming a pilot, and a little bit of those early days. I think that'd be a great way to start things off with where we're going to be going.
Yeah, so I think you have to know something about the time in history. I was in college in the 80s, and the movie Top Gun had just come out, and this was a runaway mega hit in the US. Sure. And I was in the Navy, and I had the opportunity to choose what I wanted to do in the Navy about a year after the movie came out. So it's funny because in my mind, who wouldn't want to be a fighter pilot? I mean, just kind of goes, and to me, it's a no-brainer, but I realize not everyone. It took me a while to realize this, though, that not everyone likes that kind of lifestyle. So because I had the opportunity and I had really good grades at the Naval Academy, I was a high enough rank in my class where I got my first choice. And so, of course, I chose flight school. And then that kind of put me on that path of becoming a pilot. You go to flight school, then it's competitive at flight school because it's not clear not everybody gets to fly jets. Mm-hmm. So you have to be really, really good in flight school to fly jets. I think it's probably no secret that I'm competitive. And so, I got in there and worked hard, and I do have a need for speed. And so I did well enough in flight school that I went jets, and then, everything the rest of my life wrote itself in terms of my Navy career. But I got my wings in 1991, and then I had to move to, I went to a squadron in the Philippines. And then eventually the combat exclusion law was repealed. And what that meant is that by that time I had been flying little fighter A4 planes, but I couldn't be in combat. And in 1994, the combat exclusion law was repealed, and that allowed me to be in combat. And that's when I moved to the F-18. So I flew the F-18 for 3 years, and it was just social upheaval. The guys were not happy at all. And you can read more about this in my book. I mean, they just did not want to integrate flying fighters to women. And it was a real struggle. And it's the reason I left, because, by this time, I didn't want to continue to do a job where people hated me. I had decided that I needed to have a more positive work experience. And at that same time, I figured out I had seen so many of my friends die or peers die in the F-18. The 3 years I flew them, on average, one person died a month. That's 36 people dying, and it was never in combat. It was always some kind of human-machine interaction problem. So that was my real motivation to go back to school, get my Ph.D. And so I did. I went to MIT for 10 years, which was a fantastic experience. And then I decided that, I had a baby, and I decided that I didn't want to raise my baby in Boston. And I moved to Duke, where I've been ever since. And, this career that I've had of trying to address the human-machine interaction, it was definitely rooted in my time as a pilot. And I spent the first few years doing work in aviation, human factors. But then I saw the writing on the wall that there was going to be a huge problem in the driving assist and self-driving technologies. And indeed, I had been asked to testify in front of the Senate Commerce Committee in 2014 about whether or not drones should be allowed to fly in the national airspace. And I'm very, very pro flying drones. Mm-hmm. And then on my way out the door, literally, I turned over my shoulder and I said to the staff, you know what's coming next? It's going to be self-driving cars. And then, it just turns out, if you make the right prediction in front of the right people, they were really surprised by what I said. But then 2 years later, they called me back to testify again, this time about self-driving cars. And so I'm very, my opinion about them is very different, where I'm extremely positive and supportive of unmanned aerial vehicles in the national airspace. Self-driving cars are a different situation. And that just goes to show you that even if you think tech is the same across domains, it's not. And so ever since then, I've been kind of on this one-man Don Quixote-esque attempt to warn people about the real immaturity of artificial intelligence and self-driving systems.
And
that's a very long answer.
No, it's a great answer, because I'm going to go through each of those areas because they link together very well. And I'd like to start off. You're talking about all the crashes that were occurring during your time flying the F-18s. You did your Ph.D. And then the title, the Designing Decision Support Systems for Revolutionary Command and Control Domains. And in this, you go into these adjustments to something known as cognitive work analysis, which I guess was sort of the standard for how you put together at the time these computer-human environments. And you had proposed these aren't good enough. There's a lot of crashes going on. We got to change these around and add some different components in terms of looking at the social and ethical part of it, but also various simulated aspects. Obviously, I don't want to give you a dissertation again, but can you walk us through a little bit about what that was all about, what cognitive work analysis was, and how you modified it, and saw the need for modifying it?
When we talk about cognitive work analysis, it means different things to different people. Mm-hmm. I use the words cognitive work analysis really to mean any analysis of how either people or groups of people cognitively go about whatever their jobs are. Some people think that cognitive work analysis is a very specific set of procedures as published by Ken Vicente, which I disagree with. And indeed, that is what my dissertation is about. My dissertation really highlights the fact that that methodology, if you try to follow it religiously, it's deeply flawed, and it's going to not necessarily, it won't always give you the right results. But I also want people to understand, even though I'm saying, look, however you think about cognitive work analyses, I think it's more important to think about that phrase as a collection of tools. And that collection of tools really is, for the most part, just talking to people about their jobs. That is the most important thing. And I think that is the most, it sounds trivial, but it is amazing to me how many engineers really hate talking to users of technology. And I see this in computer science. I see it in electrical and computer engineering. I see it in biomedical engineering. That is the worst. Like the technologies that touch humans the most, I see engineers really almost, when you say to them, well, have you talked to your users? They recoil and they're aghast. Ew, no, talk to the users. No, why would we do that? So I think it's really important for people to, I don't want to act like I'm on a platform to say one approach is better than another. I really don't discriminate between cognitive task analyses, cognitive work analyses. They're just work analyses. They're how people go about their jobs. Sometimes they're primarily cognitive. Sometimes there's a lot of physical interaction. I just finished a sabbatical with Amazon Robotics, and I would say a lot of what I did was combining cognitive work analyses with actually good old-fashioned ergonomic analyses, because they've got these pickers who pick goods out of one bin and put them in another. And the way that they design these, there is some cognitive aspect of it, but there's obviously clearly a physical aspect. And so I also want to make sure that people don't forget, like, good old-fashioned techniques that were useful in the 70s can still be useful today.
Moving then from, say, understanding that, okay, there's, despite the fact we have this fancy piece of equipment, once again, it comes back to the person that's operating it. And I for some reason, I'm a fan of this show that it's basically called Why Planes Crash. And sort of the takeaway for me, I do not have a background in aerodynamics, aerospace engineering, and so forth, is that with the exception of the catastrophic stuff, the bombs and pilot suicide or whatever, for the most part, most of these plane crashes are avoidable. There's some little thing that's missed. And so I come now to this article that you were quoted in a few times, Plans for Self-Driving Cars Have Pitfalls, The Human Brain, where it goes into the fact that, once again, and not really thinking this all through, that we're all making, or the automakers are making an assumption that that when something does fail, then I'm in a position to fix it really fast, like an experienced fighter pilot. But no, all this research is showing that my mind isn't focusing on that stuff when I'm driving around in my self-driving car. The mind does a bunch of other stuff. Talk a little bit about what you've learned as far as, especially when it gets back to sort of the brain, what types of stimulation we are looking for when we're in our self-driving car versus what we're not planning on doing in terms of the boring tasks, and some of these issues that deal with the human side of the self-driving car issue.
So I'm not sure what the question is.
The question is, talk about the unreliability of me taking over that failing self-driving car.
Okay, so you really want to talk about how reliable humans are in taking over, or how should we think about doing, for example, task analyses, or how should we think about the role allocation of what humans and computers should be doing? Because those are slightly different things.
I'll take a little bit of all of it if you want, whichever direction you want to go with it.
Okay, so let me step back and say, we've known for a while, I think it really came to pass in the 1990s with a series of Airbus accidents in the 90s, that there was conflict between what the humans thought that they should or should not be doing and what the automation was or was not doing. And this started the rise of, I think, a big spike in human factors research and just human automation interaction research in general, understanding that engineers would design a plane, and there's many accidents that you could look at to say that the human either did not understand what the automation was doing, or didn't understand that the automation had ceded control back to them in some way, and they didn't realize that they were in one mode, expected to take one set of actions, and instead took an opposite set of actions. So, and this can be exacerbated by poor human teamwork in the cockpit, right? So there can be a lot of confusion. Indeed, the oh gosh, what is the name of that crash in San Francisco? The Japanese crash.
The one that comes to mind
Asiana. Yeah, that was the one. That's a good example of. There was a lot of automation bias going on, where the pilots thought that the automation was doing something. It wasn't actually in control. They were in control, and there's a whole team of them. I think 5 pilots in the cockpit. But we've seen this in American military cockpits too, where despite the fact that you have 5 people in a cockpit, there's just general confusion about who's in control, who being both humans and the automation. So it's been well established for a long time that in these domains where humans are supervising autonomy, that it's easy for a human to be who is not in the loop, but rather on the loop. And that means that the human is not directly moving flight control surfaces. They're not directly controlling anything. If they're just watching the automation do something, it's easier for humans to mentally check out. And we've seen this many times. Your eyes, you know this, if you've ever driven and you're listening to the radio so intently that you missed your exit. Even though your eyes are on the road, your brain can be somewhere else, and it's not that hard to be distracted, even if it's your own mind that's distracting you. And so we knew that, and indeed, Boeing has a fantastic human factors commercial air division, which we can always come back to the 737 MAX and talk about, well, what happened with that, right? There was a big spike in understanding that, at least in aviation, that these were problems. Then you fast forward to self-driving. I think one of the great aspects of Silicon Valley is that they move fast and break things. One of the bad things about Silicon Valley is they move fast and break things, because one of the problems with the ethos of moving fast and breaking things is not actually sitting back and reflecting on whether or not somebody else has done something similar and what are the lessons that we can learn from people who have done something similar. So I wrote an article in 2014, and I'm not the only one, who actually made a lot of comparisons between all of these problems with automation and aviation and what they were likely going to mean for the self-driving and or driving assist world. So summarily, myself and everyone else who sounded the alarm bells were ignored. I have to tell you, that's actually the common theme in my life is, despite the fact that you think I'm this in-your-face female who's always trying to, make people listen to me, I'm ignored quite a bit by my students, by my own teenager daughter. I'm kind of used to it across the board being ignored.
Me too.
Yeah, it's just, it's the life of the parent is learning to be ignored. And so we've been trying to warn the self-driving and driving assist community for a while that these problems were going to be serious. And I think, we were all summarily ignored, and now people are starting to die. And it looks to me, this is anecdotally, and there's still not quite enough evidence to make this a mathematical claim. But it seems to me that the frequency, at least for Tesla accidents, and I believe this is going to go higher as more and more manufacturers try to emulate Tesla, we're going to see more accidents happen because people are mentally checking out because they think the autonomy is more capable than it is. And at some point, all the human factors people, including myself, who've been wailing about, you should listen to us, we are being shown to be correct. And I think begrudgingly companies are starting to understand, and my hat's off to companies who are starting to understand that there's actually a market in developing technology that works with humans instead of either replacing them or somehow, in theory, completely taking over some kind of job and just letting you babysit the system. But it's slow in coming, and unfortunately, there have been a lot of unnecessary deaths.
What something else you mentioned at the time, and I think it was in this particular article, and I think you were talking about sort of specifically North Carolina, but obviously this applies everywhere. Aside to, from foolproofing all this stuff in terms of the self-driving cars, we also have to make them hack-proof. Is this, obviously this sounds like a really major concern, whether it's a self-driving car or an airplane, whatever, but is this something that is, an issue? Is this like on a top 10 issue with these things nowadays? Or, because you don't hear much, I mean, you hear about the self-driving cars and making sure people don't crash, but is the whole hack proof component something that you, in your, in what you see in the technology domain, everything you're involved in, something people are working on? Or if this is a confidential thing, don't, have to get into it. But that one startled me a little bit, kind of concerning.
Well, I think with the Colonial Pipeline problem, on top of solar winds, everyone is aware that the vulnerabilities around cybersecurity are real and pressing. Yeah. Indeed, it's such a big deal that I'm starting to pivot my research efforts and even my teaching efforts into that space because there's such a huge need. I'm teaching a course in the fall that looks at the human element in cybersecurity because, it's actually rare that a human is not involved. Like somehow, somewhere, somebody clicked on a link or opened up an attachment or something that they shouldn't have. Mm. And indeed, humans are starting to become real liabilities. That being said, automation or autonomy doesn't have this figured out either. So humans can be brittle and so can the autonomy. And so the real question going forward is how can we start to combine, how can we develop these joint systems where humans can provide some of the judgment and reasoning under uncertainty that the automated systems cannot. So one example of this is in some research that we just finished for the US military. We were looking at, can humans fill in the gap when a autonomous vehicle is attacked through some kind of GPS emulation signal? So this is, where you hack into a GPS system, and it's pretty, anybody can do it who's got access to the internet. It's really not that hard to hack into a GPS signal of really any vehicle that uses GPS, and that can include planes, but also cars, and basically trick the system into going somewhere where it thinks it's still going to the right location, but it's going somewhere else. And so this is a problem, right? Because the underlying automation is brittle. It can't detect that it's been fooled. And so this is where a human really would be, having their judgment under uncertainty can help understand that, wait a minute, why is my car, I was going to the Shell station, and then all of a sudden my car is taking me completely opposite direction, but it still thinks it's going to the Shell station. That's weird, right? So there is a place in there for the humans to jump in and say, you know what, the system is not working correctly. I don't know why it's not working, but it's not working correctly. So I think we need to look for more similar ways to bring humans together so that they can help autonomy understand when it's facing some uncertainty that it doesn't recognize in its own system.
Interesting. Let's move on to drones, because this is another area that you're very active in. You recently presented at the American Institute of Aeronautics and Astronautics in 2020, a paper, Acoustic Detection of Drones to Real-Time Audio Attribute Prediction. And you went into sort of there's a lot of antisocial drone stuff happening nowadays, delivering drugs to prisons and unauthorized, going on runways or whatever they're doing. And there's issues with the different ways that we detect these things. They're really a pain in the butt sometimes when they fly over me on the beach or whatever. But talk a little bit about some of what you're working on here in terms of the issues with detecting drones currently that we want to detect, and some of what you're working on in this domain.
Yeah, so I think it's interesting there's a whole science in how do professors do what we do, meaning how is it that we start out in one area and when and how do we pivot to a different area?
Mm-hmm.
And so I was one of the very first researchers to get into drone research. And that was due largely in part to my experience in the military, where I had been involved in some early testing of GPS satellites and their ability to provide accurate geolocation.
Mm-hmm.
So I was probably more knowledgeable about GPS systems early on and how that could help in unmanned systems because of the military. Then I jumped over into the commercial sphere, indeed, and I'd like to thank Stephen Colbert for that, because I was on the Colbert Report
Mm-hmm.
Early in my career, because he and his staff saw some of the work that I had been doing flying drones with iPhones. So, it's work like that both catapulted me into the limelight, which I'm eternally grateful to Stephen Colbert for that. And then later, Jon Stewart, he was also very helpful. Right. So, it's funny, I like to thank a couple of comedians for really helping me get a leg up, but it's true, it really did. And then that work, I spent a lot of years just working in the trenches. And I was actually told at MIT at some point that my work in drones was silly and not ever going to go anywhere. And I was on a dead end path. And I am really glad that I ignored those people. And I stuck to my guns because clearly it paid off. And then eventually I got tenure at MIT for my work in drones. So it is kind of funny how, you got to listen. If you're right, you got to stick to your guns.
Yep.
So, but then the technology accelerated so quickly, I knew I had to find another line of work when Jeff Bezos announced that he was going to commercialize drone delivery, which was thrilling. I was so happy. Whatever year he announced that in, it was on my birthday. So I thought, whoa, that's a great birthday present, except it means that now that I've done something that's been commercialized, I need to find something else to really do research on, right? Mm-hmm. Because once the technology is commercialized, it's great. That's what we all aspire to, but I've got to move somewhere else. So at that time, I started to see the writing on the wall about the drone incursions, the Heathrow and Gatwick, yep. But also there were many places around the country that were experiencing this. I love. There's an episode of Portlandia where people they're going to a music fest with just using their drones. And what's funny is, they are a little over the top, but they're only just a little bit over the top. I actually not sure that the Portlandia directors understood really how close to home they really were. And so it was those events that inspired me to start looking at the other side, meaning how can we defend against people who are going to use drones? And it really is, it's not really defend against the drone. It is defending against the people, right? Because it's the people who are making the decisions to do something nefarious with those drones. And so I wrote an NSF, National Science Foundation proposal, which was awarded. I teamed up with a good friend at Clemson University who's in landscape architecture, Holland Nassar. And so and this was a really fun project because it was me doing the engineering and Hala was doing landscape architecting, two fields that you think would never come together. But we just finished the paper on that. And it has some very specific, we developed a trade space analysis that could let any owner of any venue figure out what are the most important variables that I care about for my problem and what can I do to defend against drones. And so this research was really targeting people with very small budgets, not the CIA, not the Department of Defense, who have hundreds of thousands of dollars to have very complicated radar drones, and maybe you can use some some countermeasures and, you know, either shoot the aircraft out of the sky or jam them out of the sky, which has a bunch of other implications. You know, our customers are people like owners of small baseball stadiums, owners of amphitheaters, music fest directors. Like, these are people who don't have hundreds of thousands of dollars, but they do need to know when a drone is coming, and maybe where they're vulnerable. So that's really what our research did. And we showed that, you know, again, there's some technology elements that you can do, but you also need to think about behaviors, because if you understand what the behaviors are of the people who are likely going to attack you, you can actually do some very clever landscape architecting, use of trees, use of screens, right? There's actually some things that you can do, which we call passive mitigation. So you can passively mitigate people's attacks on whatever it is that you're trying to defend against. So, you know, I really enjoyed that research, and then it shows me too that, you know, where the holes are, where we as researchers are thinking about. And then of course, that's kind of led me down the deception path. So that's actually kind of where I'm pivoting now, is trying to figure out how to think about people who deceive, whether it's with drones or just basic cybersecurity hacking, and how can we defend against that?
You know, it's a couple of months ago, I had David Stout from Booz Allen on, who, you know, he's the main guy in directed energy, and aside from all the sort of laser beam stuff he was talking about this Thor thing, tactical high power microwave operational responder, which basically, I just say, if you have enough money in the military, you can zap, you know, hundreds of drones out of the sky at one time. Are once again, nothing confidential, but are baseball stadium owners and other places that you know, these drones are becoming a problem. I mean, is there sort of a business in play anywhere that, hey, we can create, as you're saying, countermeasures or that can defend against drones at a smaller level?
Yeah, well, I think this is right. This is where we are headed in the future. Is, you know, it's part of the typical technology space race. As soon as a person develops a technology, then somebody else develops a way to misuse that technology, and then somebody else has to develop a way to stop that person from misusing technology, and so on and so on. So instead of people being up in arms, you know, I would tell people, relax, you know, we're on it. And it's just part of the natural cycle of technology. And even people who are doing hacking into computers, a lot of the times people are hacking into systems just to show that they can, although I think that now we've seen what nation states or groups that are connected to nation states, like in the colonial pipeline, you know, they can they can cause real damage.
Yep.
And I am very concerned, not about the fact that there are people doing it. I'm more concerned that the United States government is not more open about its inability to address these issues. I believe the fact that we are not training a workforce inside the government, not just the Department of Defense, but across the entire government, that is technically literate in cyber, in artificial intelligence, in machine learning, for example. I find that I sit on so many boards and panels, both in the commercial world and in the government world. I think it's a pandemic of technical illiteracy that we need to be dealing with. And I find that I interact with a lot of people, for example, in the Department of Defense, who pretend that they know what they're doing, but then it's very clear from tweets or actions or whatnot that they don't know what they're doing. And I think that, you know, not that this is not the first time in history where we've had a lot of executives kind of, you know, use a lot of buzzwords and pretend that they know what they're doing. But the consequence now is, you know, cybersecurity is real, and it's kind of an invisible enemy. So if you pretend that you know what you're doing and you don't know what you're doing, then you really open this country up to more damage. And I think the colonial pipeline it actually could have been much worse than it was. And I hope that that's a wake-up call for the government to get serious about funding. We need to have many more scholarships. There's a program that the Air Force has called the SMARTS program, where the Air Force will pay for your PhD or master's as long as you give them a few years of work. I think we need to invest way more in that, especially in cyber, because people can make so much money going into commercial companies. Why would they ever work for the government? So the government has got to quit dancing around these issues and start to map out real tangible strategies for how it's going to develop a more technically literate workforce.
Yep, extremely important. Missy, a couple of years ago, you were an article in the Atlantic magazine talking about, you've been in the military, now you were in academia, and it was a very both were very hyper competitive, but you had different types of aggression on both. And now you also spend time in the private sector too. Now it's a couple of years later. How do you feel about academia now that you've been here as much as you have, and where did you feel the most comfortable across those three domains?
Yeah, well, I've actually been in academia longer than I was in the military now. So, that being said, it's interesting because I think there's a lot of passive aggressive, what people might call microaggressions, that happen in academia, whereas in the military, everybody was, at least in the fighter pilot world, was just aggressive, right? Where if people didn't like they wore it on their sleeve. They were very obvious. So I always knew where my enemies were coming from in the military. In academia, people are much more, they've got a hidden agenda and they hide it better. But indeed, that some of the damage that they can do to you potentially, can be much worse and much longer lasting. So I do, in this era of where we're having hopefully a better microscope of looking at diversity, I definitely believe that there are problems with gender diversity in engineering schools, for sure, and in academia more broadly, in the fields that are traditionally male dominated. So I think that is a struggle. But what is starting to concern me more is not so much gender diversity. And I mean, don't even get me started about racial diversity, because that's almost a losing battle, because you can't have a diverse community unless you're training enough people to start coming out the pipeline. So until we start getting people of color through, just any people of color through the pipeline, we're never going to meet the goals that we want. But related to these problems are discipline diversity. Yep. So I am just blown away at how often people will marginalize my research to my face, actually. So even academics are starting to get aggressive about basically looking me in the eye and telling me that because I do engineering, I look at engineering of human systems, and so I use squishy research methods, and somehow that makes me either inferior or not at all qualified to be in a particular field, which is funny because, I come from this very male-dominated field of fighter pilot world, so I often feel like I'm the most manly man in the room at any given time. But it is amazing to me. It's not just a problem in engineering, it's more broadly a problem in academia of interdisciplinary interactions. And every school will say that they embrace interdisciplinarity, but the reality is that professors who engage in true interdisciplinarity are punished for this. They're punished for it in tenure, they're punished for it in promotions, they're punished for it in pay, they're punished for it by their communities. So this this paper that I just told you about, where I talk about the integration of landscape architecture and the drone engineering of the drone detection system. I'm actually I'm struggling to get it published in an engineering journal because it's not considered to be technical enough, even though this article contains all sorts of really great information about convolutional neural nets and machine learning and lots of number results. The fact that there's what's to be considered squishy, you know, talking to people and considering the human and human behavior, a lot of engineers just consider this antithetical to what they do. And so that's a problem in academia in terms of recruiting and retaining people, because indeed, if we're going to increase the numbers of minorities, women, people of color, they often will gravitate to interdisciplinary fields. So it's a double whammy if we're going to abuse our interdisciplinary professors. But then the triple whammy is then we actually do not start addressing the problems at society scale. More specifically, I have been trying for years to grow an assured autonomy program where we do research into the safety, certification, and testing of autonomous systems. Air, ground, rail, car, you name it. If it's an autonomous system, we need to do more research on how to make these things safe, and how do we even know when they're safe? It's clearly a societal need. There is no greater need that we have across all transportation domains, across medical systems, across process control, manufacturing. However, every time I write a proposal, the reviewers come back and basically say, this isn't my field, this is not a good you need to put it somewhere else, you need to put it somewhere else. And when people do that, what they're doing is they're saying, look, I've got my stovepipe and it doesn't belong in my stovepipe, and you needed to find some other stovepipe to put it in. So I think we've got a problem of, and I'll tell you where it's the worst. The elite schools are the worst. I think a lot of state schools are much better about interdisciplinarity, but the top 20, maybe top 30, they say they want interdisciplinarity, but they don't. And they don't take the actions that they would need to take to make their professors successful. So it sounds very provocative. If you're in the academic world, I've basically just poked a bunch of people in the eye. But if you're not in the academic world, you're like, yeah, that makes total sense. Why aren't we doing it? Well, it's a good question. Why aren't we doing it? I think the solution needs to start with the funding agencies. I think every funding agency, to make this happen, you can't rely on the schools. The schools aren't going to do it. But if the National Science Foundation, for example, said, we are never going to fund any project unless there are two people from two very different domains on this project, that's what I believe they need to do. They need every single grant to have more than one person from a different domain on it. And if you did that, then that would force schools to change.
And this is not the first time we've heard this problem. And it's pervasive. And you're not talking to a lot of people. I think, a lot of people agree with you on this. There's not as many eyes as you might think getting poked, but it's an issue. It's an issue. We've gone from airplanes to self-driving cars to drones to drone countermeasures to a lot of other structural issues. Am I missing any interesting technologies that you can talk about, stuff you're working on that's not confidential? I want to make sure that you haven't enough time not miss anything, because I wanted to get everything you're working on out there. Have I missed anything that you might want to tell the audience about, whether it's robotics or other?
I think we've covered a lot.
Cool. Then we'll enter the lightning round. Number one, has Elon Musk ever gotten back to you and stopped picking on me on Twitter?
No. I often tell people, if I show up mysteriously dead one day, that's Tesla. It's probably the first company you should look at. I haven't, but at the same time, I try to make it clear every time I do an interview. I love the idea of Tesla. I love electric vehicles. I can't stand car dealerships. I cannot wait to move to a world where I never have to go to a car dealership again. So I want to do everything I can to support Tesla's business model in those aspects. However, I can no longer be quiet, not as if I ever was, about the problems with autopilot and full self-driving. We need to be very clear about what these cars can and can't do. And until we can get some industry agreed upon self-generated standards, then I think that we should turn these systems off. Or if he's not going to turn autopilot and full self-driving, Tesla should only let drivers use those technologies in the operational domains for which they've been designed, which is for limited access interstates and freeways, for example. So if you're not going to limit the abuse that people can do, then, I think they have, and I think the future will show they've really opened themselves up to liability and or increased regulatory action.
Got it. We'll make sure Elon gets that message. Which call sign did you really prefer? Medusa, Shrew, or Missy? What was your favorite?
I prefer Shrew. I liked Shrew the best because it was the shortest. And if you know anything about the taming of the shrew,
Sure.
That's pretty much me. I mean, Kate, that is who I am. And so I feel like even though, in theory, when you get dinged with a call sign, it's supposedly derogatory and you're not supposed to like it. I loved it. I love that call sign.
I would say if I was the enemy, I probably not want to fight someone called Medusa. But yeah, they're both equally cool. Before I let you go, Missy, we typically just give the floor back to our guests. Obviously, there's a lot of people that have been with you along this journey. If we just take a couple of minutes to mention, shout out to anyone that you want, whether they're from the Navy, from academia, from industry, from the Defense Department, wherever, you can have the floor again to shout out, mention whoever you want.
Even though I'm one person talking to you today, I am one person that represents just so many people behind me who have supported me in all these years. My students, first and foremost, are the ones that really have propelled me to greatness. I just coach them along and they've all done amazingly well. But even my funding agencies, I really obviously appreciate the money, but to a person, every funding manager that I've ever had, because you always have a technical monitor for whatever funding agency, whether it's the National Science Foundation or somebody in the DoD or even somebody in a company. Every single person has taught me something and made me see the world in a different way. And I would not have had the great research insights that I've had over the years if it weren't for my interactions with my funding agencies. The drone project, the actual kernel of that idea called when a security service to the stars in Hollywood called me and said that they were having a huge problem with drones. They were worried about drones tracking and potentially doing harm to various celebrities. And, that has been a problem over the years. And indeed, it was that phone call that made me sit back and rethink how I thought about drones and how I think about what do we really need to help people like this. And so I am so appreciative because even though I seem like I'm this genius and very successful, as a single person, it would not have happened without an incredibly large network of students, funding agencies, friends, people I talk to, even on airplanes, right? I am constantly 100% of the time doing a cognitive work analysis of every single person I talk to. So that's kind of maybe a bad thing because now nobody's going to want to talk to me on a plane because people always think I'm super nosy, but that's just because I want to find out about people in the world. And all those people have been really critical to my career.
Wonderful. It's been a fascinating career. I mean, really, this is incredible stuff you're working on, and just really wishing you the best with all this. And, you know, I hope the system modulates itself in the correct direction, so you get you know, an endless source of funding for anything you want to do, because it's just so important, especially with everything coming at us now, and sort of on the bleeding edge in this domain. Really, really fascinating stuff. For everybody that's going to be listening to this particular episode on the podcast or watching on our YouTube channel, you've been listening to Dr. Missy Cummings, Professor, Department of Electrical and Computer Engineering, Pratt School of Engineering at Duke University, Professor at Duke Institute of Brain Sciences, Director of Human and Autonomy Laboratory in Duke Robotics. Missy, this has been a really fascinating discussion. I just want to take the time and thank you for taking time out of your schedule to talk to us. Thank you for everything you're doing. Thank you, of course, for your long service to the country. And as we say on our show, thank you for helping to create a better tomorrow through everything you're working on and researching. It's really, really been a great time, very inspiring.
Thanks for having me.